Hello, fourth grade, and welcome to topic 15. The first lesson we're going to cover is about lines, rays, and angles. So we're getting into geometry here. We're going to learn a lot about these different things and see plenty of examples. Let's go ahead and watch our short video lesson, and then we'll get into our notes and our guided practice together.
What are some common geometric terms? Think about this question during the lesson. Point, line, line segment, ray, right angle, acute angle, obtuse angle, and straight angle are common geometric terms. A point is an exact location in space. This is point Z. A line is a straight path of points that goes on in opposite directions. This is line AB. A line segment is a part of a line with two endpoints. This is line segment GR. A ray is a part of a line that has one endpoint and continues on forever in one direction. Lines and parts of lines are named for their points. A ray is named with its endpoint first. What is a name for this ray?
Select your answer.
This is ray NO. An angle is formed by two rays that have the same endpoint. Angles are named with 3 letters. The shared endpoint of the rays is the center letter. The other letters represent points from each ray. Angle ABC is a right angle. A right angle forms a square corner. Angle DEF is an acute angle. An acute angle is open less than a right angle. Angle GHI is an obtuse angle. An obtuse angle is open more than a right angle, but less than a straight angle. Angle JKL is a straight angle. A straight angle forms a straight line. Is a line segment also an angle? Explain. No. A line segment is not made up of 2 rays with a common endpoint. A straight line forms a straight angle, with one point of the line acting as the endpoint for the 2 rays. Can an angle be classified as 2 different types of angles? Explain. No, an angle can be only one of these 4 types of angles.
Now you know some common geometric terms.
All right, let's get into our notes and our guided practice. Now, this is basically just an introduction. You're just getting to know these terms and what they mean and what they look like. So don't worry too much. Now, what are some common geometric terms that we talked about? We said a point is an exact location in space. So over here, I'm going to use the same example they used in the video just to be consistent. So this is point Z. This is an example. You label it as point Z, and when you look at it and you want to say the name, you're going to say point Z. A line is a straight path of points that goes on in opposite directions. So it goes forever this way. It also goes forever that way. When you want to label it, you draw a line AB and you draw the 2 arrowheads on either side to show that it goes out forever. And you label it line AB. Now the next one is a line segment. A line segment is part of a line that has 2 endpoints. It doesn't go on forever. This is the entire thing right here. So this is line segment GR, and you draw it like this. So you're drawing the little line without the arrowheads on the end. And that's what tells you that it's a line segment. Next, we have a ray. A ray is part of a line that has one endpoint and the other side goes on forever. So this is the end of this side, and this side will go on and on and on forever. When we draw it, we draw ray NP, where it has an arrowhead just on one side. Now next, they talked about angles. So we're going to get in and talk about angles. So we have 4 types of angles, like you saw in the video. We use a tool called a protractor to measure angles. Now, sometimes it'll have this nice, helpful swivel. Sometimes it won't. And I'll show you how to use this in just a moment. So the first type of angle we're going to talk about is a right angle. So this is the symbol for angle. So angle ABC is a right angle. A right angle forms a square corner. And if we're going to measure it, when we measure angles, we measure them in something called degrees. That's the unit. So this forms a 90-degree angle. So this is 90 degrees. So you draw the 90 and you put a tiny little circle above it. Now, if I want to measure this, this middle part is going to be right there over that shared ray. So you're going to line it up. Now here on the protractor, you can see that it's got a little line right here and a little line right here. So you can line it up with what you're working with. So I'm going to put it like that, and I'm going to line it up. You see them? I'm going to line them up. And then if I have one of these swivels, I can use it to help kind of trace up and see where my line is. So I see this line is pointing up. It's going to take me to the 90 degrees. Now, the way that I'm measuring this, since my angle starts from here to here, I'm going to start from this side being 0 and going up. So you see how there's numbers on the inside. Let me pick this up for you guys so you can see. There's numbers on the inside that go from 0 all the way to 180, and there's numbers on the outside that start on the opposite side that go from 0 all the way to 180. You want to look at the way that your angle is open. So if it's open this way, you're going to start measuring from wherever 0 is on the side that is open. So here, I'm going to be measuring using this 0. I lined up my lines, and then I can use this handy tool to show me that this is pointing all the way to about 90 degrees. Okay, so the second kind of angle that we're going to talk about is called an acute angle. Now, an acute angle measures less than 90 degrees. It's open less than 90 degrees. So here you can see this is what a right angle would have been where the dashed line is, and this is open less. So this is angle DEF. Remember, the middle point, that shared end point, is going to be your middle layer because it's the middle point in between. So angle DEF is an acute angle, and an acute angle is open less than a 90-degree angle. So anything from 0 to 89 degrees is going to be an acute angle. So I can take this, again, it's open to the right. So I'm going to use my measurements that are here on the inside. I'm going to line it up, make sure the line over here that's on my protractor lines up with the line that I have over there, and my end point is inside that little circle. And then I can take this and I can line it up with my line. I can see that here I'm measuring a little bit right in between 120 and 110 degrees. Now, one thing you can do is if your line is too short, you can draw it out and extend it out so you can see exactly where it hits. So sorry, that measured between, I was using the wrong measure side. So remember, we're using the inside because it's open to the right. Since it's open to the right, we're going to start on the numbers that start from 0 on the right. So again, we're going to line it up, and then we'll take this and we'll line it up as best as we can. So you can see here we're measuring about 60 degrees. So this is nice because it has a little hole in each section for you to help you find your number. Now, an obtuse angle is an angle that measures more than a right angle, so more than 90 degrees. Anything from 91 degrees to 179 degrees is going to be an obtuse angle. So here you can see where the right angle would have been. You can see it's open even farther. So again, you can take your protractor. If you want to measure the angle, line it up. Take this and line it up with where your line is pointing. We can see this one is about 120 degrees. You can see that right there. And last, we have what we call a straight angle. Now, a straight angle makes a straight line that measures 180 degrees. Now, here you have to look at this as two rays. So this is a ray that's going this way and a ray that's going that way. So if I measured to go from here to here, that's a right angle, that's 90 degrees. And then from there down to there is another 90 degrees. So think of it as two right angles that are standing back to back. 90 plus 90 is 180. That's how you know the measure of a straight angle. A right angle is 90 degrees. A straight angle is basically two right angles next to each other, and you want to measure all the degrees all the way from one end to the other. That's going to be 180 because it's going to be 90 plus another 90. Now let's take a look at another example. Here we're going to work on some matching. So we're going to use the clues to help us match the vocabulary and their meaning. Now this is only a few of the words that we've gone over, so it's not everything. A part of a line with two endpoints. We know that's a line segment. Remember, a line segment is not, it doesn't have the arrowheads. A line segment will look like that. So we can say this is line segment AB. If we're going to write it, we're going to write like this without the arrowheads. A set of points in a straight path that go on forever in opposite directions. So if we have something that looks like this. So let's say this is CD. Now, since we have endpoints on both, or we have arrowheads on both sides, that means it goes out forever. This is line CD. So when you draw it, you put the arrowheads on both sides to show that it's a line. Next, we have two rays that share the same endpoint. That's an angle. Those are what we've been working with. So we'll label our angle EFG. Now we also know that this right here is an acute angle because it's open less than a square corner. It's less than 90 degrees. And an exact location in space is a point. We can say over here, this is point H. And we just label that point H. Now let's take a look at another example before we jump into our guided practice. This is one of the ones that are in your book. It is also one of the ones that seemed to be one of the more confusing ones for you guys. So I wanted to use it as an example to walk you through how they found it. Now, this is a little bit more than what you need to know for this lesson, but it's good practice because you're going to use that information later. It says, Nina says she can make a right angle with an acute angle and an obtuse angle that have a common ray. Is she correct? Draw a picture. So over here, we have her obtuse angle is ABD. Her acute angle is ABE. So over here, AB is the ray that they share. It's either going to go out to D or it's going to go in to E. Now, if we say that angle ABD measures 120 degrees, so we used a protractor and we measured it to be 120 degrees, and ABE measures 30 degrees. We can find the measure of EBD over here, and this is going to measure 90 degrees, so it'll make a right angle. But why does it make a right angle? Let's stop and think. So ABD, this big open wide one, is 120, and the little one, ABE, is 30. Now to find EBD, I'm going to take the whole thing minus this little part, because I want to find out this part right here. I want to find out how open this part is right here. So I'm going to take the whole thing minus the little piece to find this inside part. So 120 minus 30 is going to give me 90. So angle EBD, this one, is going to measure 90 degrees. So we took the whole thing minus the part that we didn't need to find the remaining part in here. This is not something you need to know how to do just yet, but it is a good introduction. So this is just subtraction. You have a whole piece, you take away a part of the piece to figure out what's left. So they wanted to figure out how can we make 90? What minus what will give me 90? So they took a measurement of 120, and they know 120 minus 30 will give them 90. So they drew a 120-degree angle, and inside of that, a part of that was a 30-degree angle. So the part that's going to be left over is the 90-degree angle, because 30 plus 90, so this piece plus this piece, which is going to give me this whole thing, which is 120. Okay, now for a guided practice, they're asking you about some of the terms. So what geometric term describes a part of a line with one endpoint? So one endpoint is called a ray, and this is an example. So you needed to draw. So not just write the term, but also draw an example. So this is ray AB. I have one endpoint. The other side goes on forever. Number two, what geometric term describes a part of a line that has two endpoints? So two endpoints means it stops. That's the full section right there. It doesn't go past that. So this is line. This is called the line segment. Line segment CD is what I drew over here. This is the total length. It doesn't go out any farther than this. What's a geometric term that describes an angle that forms a square corner? That's called a right angle. This is right angle EFG. Number four, they gave us examples for 4 through 7, and they wanted us to name the geometric term and to write it out and to label it. So this over here has two endpoints. We know this is a line segment. This is line segment PX. So you see how it's just that little line with no arrowheads. Number 5, you can see that here they drew the little square corner. So we know this is a right angle, and this is angle PQR. For number 6, we see one endpoint and the other side that goes on forever. So this is a ray. We call this ray BY. And for number 7, we have this angle over here. We see it shares an endpoint, so we know this is an angle. We know it's open less than 90 degrees, so we know it's an acute angle. Acute angle LMN. That takes you through this lesson. This was just an introduction to these different terms, getting you familiar with them because you're going to learn more about them as you go. If you have any questions, let me know. Otherwise, have a great day. Take care. Bye-bye.